Recording in progress.
Hello everyone. Welcome to Mathematics with Shahab Yaqub. So now tomorrow, 2nd May, it will be your P1 paper, variant 1-2. Variant 1-3 has already occurred in some other region. So now we are preparing P1 with some very, very nice questions. Yes, you have already done your part. Now it's time to relax, chill, and just have a look at some of the selected questions, very nice questions that I think have a chance, a wild chance maybe, to appear in tomorrow's exam. Any which way, they will brush up your concepts. So sit back, relax, and have a look. Now I'll be focusing on coordinate geometry, circle, circular measure, trigonometry, quadratic functions. I've skipped binomial, AP, differentiation, integration. So now let's start with circle equation. Now in circle equation, a little bit is done. So let me first erase this part. Let me make you think. And then what I'll do is that I'll show you the solution. So now first the question says that a diameter of circle C1 has endpoints such and such. Find an equation of circle C1. So if I draw a line like this, and this is one point A, this is the other point B, let me find the midpoint. This midpoint is the center of the circle. From midpoint to any endpoints, this is the radius of the circle. Second thing, the circle C1 is translated by this vector to give circle C2. That means this is the center, this is the other center. What has happened is that we are moving 8 units to the right and we are moving 4 up. So 8 right, it's not drawn to scale, 4 up, and what you are getting is the new center. Now remember that in the concept of transformation, when we talk about translation or reflection or rotation, the area is unchanged. That means the radius remains the same. The radius is the same as before. So we take the center, we add 8, 4, and then we get the new center. So the old center plus 8, 4, we will get the new center. And then we will write down the equation x minus h whole square, y minus k whole square is equals to r square. And now the two circles intersected points R and S show that the equation of the line is this. Now the idea over here is if this is a center, then this line over here, which I'm drawing again, I think this is R and this is S. This line is actually the perpendicular bisector of the line joining the 2 points. Which 2 points? The center of the circle. So circle C1 for circle 1, C2 for circle 2. And then hence show that x coordinate of R and S satisfy this equation. So let me show you the working. This is the mark scheme. And this is my working. So first of all, this is A, this is B. Apply the midpoint formula. Explain everything. Do not assume anything because this is where you make a mistake. -5 plus 3. In a hurry, you said 2. 2 divided by 2 is 1. And then everything will have a negative domino effect. And then the radius R, leave the answer in square root form because any which way it will be squared over here. Draw a diagram for your own convenience. And then this is the old center, 8, 4, new center, radius remains the same. That's how you write the equation. And then the two circles intersected point R and S. Method 1, solve the two equations. Make them equate one another. The x square, y square, x square, y square cancel, simplify, you get this. Method 2 is what I just explained. Find the midpoint of those two centers. Find the gradient of the line connecting TW. This comes out to be positive half. Do the negative reciprocal for the perpendicular and find the equation of a line. The line is written right over here. Hence show that the x coordinate of R and S satisfies this equation. So I'm taking circle equation 1. I'm taking equation of the line RS. I'm equating it to one another and I get this quadratic and you don't have to solve it. You leave the answer as it is. Now the next question, again, some working is done. Let me erase all this working so that you can simply read the question and then I'll show you the explanation. The equation of circle with center such and such as 0, find the radius of the circle. Now this is known as the general form of a equation of the circle. We have to convert it into x minus h whole square, y minus k whole square is equals to r square. This is called the completed form, square form. So I'll show you the process. Then it says the point P12 lies on the circle. Show that the equation of the circle, tangent to the circle, is this much. So now what is the concept? The concept is there is a center over here. There is a point over here, just a rough diagram, and that's how a tangent is there. So what we do is that we find the gradient of PC, whatever that comes out to be. Gradient of tangent should be negative reciprocal of gradient of PC. We will use the point C. We will find the equation of the tangent. And then it says this thing, the point Q also lies on the circle and PQ is parallel to x-axis. So let's say over here is Q, over here is Q. This line is parallel to x-axis. That means the y coordinates are the same. Keep that in mind. Now over here is the center. So now the rule that we will apply over here is that if I draw a line like this, and this is the baseline, if this is the radius, this is the radius, this is an isosceles triangle. If I draw a perpendicular, therefore this point will be divided equally. We will use the concept of midpoint over here. Now the two tangents meet at T. That means this is one tangent. Let me draw another tangent like this, and the other tangent would be at Q, and they would meet at this point, that is T, that is simultaneous equation. So now let's look at the working. So this is the working for the first part. It says the equation of a circle with center C is such and such. Find the radius of the circle and the coordinates of C. So x squared minus 8x plus y squared plus 4y equals to 5. These two terms together, constant transferred to the other side. First add, then subtract square of half the coefficient of x. First add, then subtract square of half the coefficient of y. Make sure the coefficient of x squared and y squared is 1. If it's not 1, we would multiply throughout by that coefficient, and then we would proceed. And the rest of the story is the same as before. This is the equation of the tangent. The gradient of PC, it's over here, negative 4/3. Gradient of tangent plus 3/4. We have the coordinates of P. We find the equation, and this answer is for confirmation purposes. The point Q also lies on the circle, and PQ is parallel to x-axis. So P is 1, 2, Q is Q, 2, C is 4 and minus 2. So focus on this 4, focus on 1, focus on Q. 1 plus Q divided by 2 is 4. 1 plus Q is 8. Therefore, Q comes out to be 7. I have also explained it using a number line. Now we have Q, we have this gradient. Now the question is, how do we get this gradient? Now, if this angle is going like this, if this tangent, it has an angle of theta. If this tangent is going like this, it has also an angle of theta. That means the inclination is the same, but this one is positive, this one is negative. It has nothing to do with negative perpendicular, negative reciprocal. So this is plus 3/4, this is minus 3/4. We find this equation, we solve it simultaneously, and we find the coordinates of T. So that was all about circle equation. And that's how this question is done. Now let's move to trigonometry. Now in trigonometry, we will be having a combination of functions also, and some identities also, and all these things should be there. So now let's look at this question. Now what does this question say? This question says function f and g are such that fx is 2 minus sine 3 sine 2x for x between 0 and pi. And then it says gx is negative of 2fx between x between 0 and pi. State the range of f and g. Now, the first thing first is that if I talk about fx, and let me write all the details related to it, because that will be needed in the later part. Fx, this is negative 3 sine 2x plus 2. And when we talk about it, what else do we observe? We observe that there are two cycles in 360 degrees, which is the same thing as 2 pi. Pi is 180 degrees. Therefore, in 180 degrees, there should be half a cycle. Instead of 2 cycles, it should be half of 2, which is 1 cycle. That is the first thing. Now, the next thing that's over here, which is the value of sine, or for that matter, cosine. The maximum value is 1. The minimum value is -1. So therefore, -3 into 1 plus 2, that comes out to be -1. And -3 into -1 plus 2, that is 3 plus 2 is 5. Therefore, -1 is the minimum and 5 is the max. That is the first thing. Therefore, let me write over here, the range of fx is between -1 and +5. That's the answer for this. Now, when we talk about gx, what happens? It's in the same range, and gx is -2 times fx. Now, because of this 2, what will happen? That -1 is becoming, actually, let me use -2. -2 into -1, that will become +2. And -2 into +5 will become -10. So now it's reversed. It's reversed because of that negative sign. So we have -1, that's becoming +2. And then we have +5 becoming -10. So therefore, the range of gx, it lies between +2 and -10. Let me just double check the answer. Fx from -1 to 5, and this is from -10 to 2, and this is negative of this thing. So this one is 5, -3, and this is -1, and that is all good from -1 to 5. That is perfect. And now 5 becomes -10 to 2, and this is all good. So instead of writing in a range, they have written it like this. I prefer that you write it like this. Okay, so this thing is done. Now the next thing. Now it says, sketch on this diagram the graph of y is equals to gx. Now fx is there. So now over here, this is this thing +2 over here. So if this is +2, let me draw this line like this. So this line is like +2. Let me make it even more thinner, but that's not a possibility. So that, therefore, I'm making it dotted like this. So this is y is equals to 2. And then this is -1. So this is -1, and this point is +5. So that's how the graph is drawn. Now we have to draw the same number of cycle, because only the amplitude is changed and it's flipped. So now it's from -10 till +2. So instead of -1, it's going down like this. Just have a look. So it's flipped. Now this point is over here. This point is over here. This point is common. This point is common. This is over here. So basically, this was 5. This is -10. And this was -1. This is +2. And that's how the thing is drawn. Now it says, sketch on this diagram the graph. That's done. And then it says, the function h is such that hx is gx plus pi. What does it mean? It means shift gx pi units to the left. That is the reason they have changed the range of values of x also. The range of values of x was 0 till pi. So originally, gx was between 0 till pi. Now over here, what they have done is that they have subtracted pi, so it became -pi. They have subtracted pi, it became 0. So it has been shifted. Describe fully a sequence of transformation that maps fx onto hx. Now, what is fx? Fx is this one, 2 minus 3 sine x. Let me write it like this. Fx is fx. And then gx is -2 of fx. And then hx is g bracket x plus pi. So what is the sequence of transformation? First of all, this is stretch parallel to y-axis, and scale factor is -2. Or you can say the scale factor is +2, and then you flip it. And then what about hx? What is happening over here? That is right over here. It is a horizontal shift. And you should always write the translation vector, which is 0 and -pi. And it's along x-axis, and of course, it also says horizontal. So that is the sequence of transformation.
Recording in progress.
So now let's look at this question. This is October-November 2020, variant 1-2. A curve has this equation, y is equals to 3 cosine x plus 2, x lies between 0 and pi. State the greatest and least values of y, sketch the graph, and then there is some special parts. So now the first part is pretty basic. Cosine for any value of x has a maximum value of 1 and a minimum value of -1. So therefore, 3 into 1 plus 2, that comes out to be 5. 3 into -1 plus 2, that comes out to be -1. So greatest and least values is another way of asking for the range. So y lies between -1 and 5, just like in the previous part. Sketch the graph of y is equals to 3 cosine x plus 2. So let me just draw a graph like this. And cosine to x, that means 2 cycles in 360 degrees, which is 2 pi. Therefore, in 180 degrees, we draw 1 cycle. The maximum is 5, the minimum is -1. Let me also draw a line over here, which is, let me draw it a little bit above. So this is the line, y is equals to 2. And the maximum value is 5, somewhere over here. The minimum value is -1. And let me draw the graph a little bit thicker, something like this and like this. So now that's how the graph looks like. This is pi, this is pi by 2, this is 0, this is y is equals to 2. Maximum is 5, minimum is -5. Now it says, by considering the straight line y is equals to kx. So let me highlight this. Y is equals to kx, where k is a constant. State the number of solutions of the equation such and such for x between 0 and pi in each of the following cases. Now, k is a constant. It's y is equals to -3x, y is equals to +x, y is equals to +3x. Now, over here, you need a little bit of accuracy. We know that pi is 3.142. We know that 2 pi is 6.284. Let's proceed with this. If I have y is equals to -3x, if I have 0, this is 0. That is obvious. That is the same over here. That's the same over here. And when x is pi, 3.142, y is -3 of that. So that means this line will be very, very steep, maybe something like this. So this is C part 1. There is no point of intersection, therefore no solution. Y is equals to x. Now over here, pi by 2 is approximately 1.57 something. So pi by 2 is 1.57. Therefore, this would be somewhere over here. So let me draw the other line, the purplish line, and this line goes like this. So this is the answer for C part 2. It's intersecting at 2 points. So therefore, we will say there will be 2 solutions. So this kind of working has to be done. And then the third one, y is equals to 3x. So at 1.57, it should be 3 times that, 4.5 kind of thing. And let me draw another line, something like a greenish, reddish line, something like this. So let me just pick this thing up, and that goes like this, something like this. So this is C part 3. So it's a concept of graphical solution of equation and gradient. So therefore, we will say there is one solution, only one point of intersection. So these are some of the best questions of trigonometry in my view. So let's move to the next kind of paper. So we'll just take a small pause over here, a break.
Recording in progress.
So now let's look at some series APGP questions. Look at the first question. The question says a woman's basic salary for her first year with a particular company is $30,000. That is the basic. And at the end of the year, she also gets a bonus of $600. For her first year, Express has bonus as a percentage of her basic salary. That is something very basic. 600 divided by 30,000 into 100. Cancel off the zeros. 1, 2, 3, 4. 1, 2, 3, 4. 6 over 3. That is 2%. Now it says, let me also highlight this. At the end of each complete year, the woman's basic salary will increase by 3%. And bonus will increase by $100. So there is a basic salary, there is a bonus. So this is basic. And that is for the first year is 30,000. And then there is an increase of 3% increase. And the bonus, the first year is $600. This is also dollars. And there is an increase of $100. Express the bonus she'll be paid at the end of her 24th year as a percentage of her basic salary paid during that year. So now, first of all, this is a GP. Whenever a percentage question comes, remember it's a GP. Common ratio is 1 plus the percentage in decimals if it's an increase. And R is 1 minus that percentage in decimals if that is a decrease. Since this is increase, therefore R is 1 plus 3 over 100. That is 1.03. This is the first term A. We want the salary in that 24th year. That is AR23. That is 3,000, actually 30,000 into 1.03 raised to power of 23. Leave the answer as it is for right now. And what about over here? This is an AP. The first term is 600. The common difference is 100. We are looking for the bonus she'll be paid at the end of her 24th year. So now what we will do is that we will write that the 24th term, that is A plus N minus 1 into D. That is 600 plus N minus 1. That is 23 and D is 100. So that is 2300 plus 600. That is 2900. Now let's double check. We have this 2900. We have this value, which is 59207.60, 59207.60, and we want the percentage. So therefore, 2900 goes up, 59207.60 goes down into 100. Use a calculator, and this is the answer that you get, 4.9%. The next question. Now it says the first term of a progression is sine squared theta. Theta lies between 0 and pi by 2. The second term of the progression is this much. Given that the progression is geometric, find the sum to infinity. So first term is sine square theta. Second term is sine square theta, cosine square theta. If it's GP, then the common ratio is T2 over T1. So this is T2, this is T1. This comes out to be cosine square theta. Find the sum to infinity. Sum to infinity is A over 1 minus R. A is sine square theta over 1 minus R is cosine square theta, which is sine square theta over sine square theta, which comes out to be 1. So the sum to infinity is 1. No harm in double checking. So therefore, this answer is 1. Now the second part, it is now given instead that the progression is arithmetic. So if it's an AP, find the common difference of the progression in terms of sine theta. That's the first part. Find the sum of the first 16 terms when theta is pi by 3. So again, write it. A is sine square theta. So A is sine square theta, and A plus D. This is T1. This is T2. A plus D is sine square theta, cosine square theta. Now the common difference is T2 minus T1, which is sine square theta, cosine square theta, minus sine square theta, which can be written as sine square theta common, cosine square theta minus 1. Now remember, sine square plus cosine square equals to 1. Therefore, cosine square minus 1, I'm taking it to this side, that is negative sine square. So this is sine square theta into negative sine square theta, which is negative sine power 4 theta. So that's the common difference. Find the common difference in terms of sine, perfect, and find the sum of the first 16 terms. So if theta is pi by 3, A is sine of pi by 3 whole square. which is root 3 over 2 whole square, which is 3 over 4. And the common difference is negative sine theta raised to power of 4. This is negative sine pi by 3 raised to power of 4. This is negative root 3 over 2 raised to power of 4. Now, root 3 over 2 whole square is 3/4. So basically, this is negative 3/4 into 3/4, which comes out to be negative 9 over 16. That's the common difference. Sum of first 16 terms, that is n divided by 2, 2a, n minus 1, which is 16 minus 1 into d, and d is negative sine 9 over 16. Use a calculator, and then you get this value. So that part is missing over here. So that's how it's done. So that completes AP and GP. Now let's move to quadratics and functions. Now it says the function f is defined by such and such. Determine whether f is an increasing, decreasing, or neither. So it's about differentiation. So it's functions with differentiation. Fx is now written as 3x plus 2 raised to power of negative 1. F prime x differentiate. Negative 1 comes down. 3x plus 2 remains as it is. Let me thicken the marker. And power reduces by 1. Derivative of the bracket is 3. So this is negative 3 over 3x plus 2 whole square. And yes, there is x square also. There is x square also. Therefore, this is 2x. Therefore, this is 2x. Now, x is lesser than negative 1. We'll think about that. Focus on this. This is perfect square algebraic expression, PSAE. This thing, the red thing, 3x plus 2 whole square can be 0, can be positive. It will be 0 when 3x plus 2 equals to 0. X is negative 2/3. Is that part of the domain? I don't think so. Because this is 0. This is negative 1. Somewhere here is negative 2/3. It's outside of the domain. So no, it's outside of domain. Therefore, for all other values, what will happen? This bracket will be positive. So 3x plus 2 whole square will be positive. But remember, there is a negative at the top. So negative 3 over positive will be overall negative. What about the 2x? The 2 into negative 1 and lesser will also be negative. So now this is negative, this is negative. F prime x overall is negative. Therefore, the function is a decreasing function. Decreasing, negative gradient. Increasing, positive gradient. And yes, the answer is decreasing. Now look at the working. They have not explained in that much detail, but they require from you in full detail. So keep that in mind. Now let's move on to the next question. This looks like transformation. What does it say? It says in each of the parts A, B, and C, the graph shown with solid lines, y is equals to fx. Let me just double check one thing, that the recording is on point. So now it says y is equals to fx. The graph shown with broken line is the transformation of fx. First one, this is the fx, and this is like reflected in y-axis. So therefore, we will write y is equals to f of negative x. That's the answer for this one. What about this one? With broken lines. Now focus on these points. Let me focus on this point. This is 2, 1. And it's becoming 2, 2. Focus on this point and this point. So 3, 3 becomes 3, 6. And I think that's more than enough evidence. What I see is that the x coordinate remains the same. The y coordinate doubles. So if the y coordinate doubles, therefore, what will I write? I'll write y is equals to 2 times fx. This is stretch parallel to y-axis with scale factor 2. That is what is shown over here. Now the third one, state in terms of f the equation of the graph with the broken lines. Now this looks like translation. This is 2, 1, and this is negative 2, negative 2. So basically, we are moving 1 unit, 2 units, 3 units, 4 units to the left, and 3 units down. So the translation vector is negative 4, negative 3. Yes, it's a translation with the vector given and state in terms of f. So they're not asking us to describe it, but we need the description anyway. So we will write y is equals to f bracket. -4 will be written as +4. And -3 will be written as -3. Now let's double check. This is good. This is good. This is good. That's how it's done. So now some blank pages and then a question. So now the first part, that is about the completed square form. Second part is about domain, range, inverse kind of thing. Third part is about composite. And fourth part is that composition thing which people fear. So let's get started with this. Now the composition thing, it's only for lesser marks. So don't be overwhelmed by it. I mean, try it out with convenience. Now the first thing, that is express this thing. So now we will write 2 common, x square plus 6x plus 11 over 2. That is a necessity. Now 2 outside, x square plus 6x plus bracket square minus bracket square plus 11 over 2. What goes inside the bracket? Have the coefficient of x. Rewrite the first 3 terms as a perfect square. This is -9 plus 11 over 2. Don't forget, there is a 2 waiting on the outside. Now, when we open up the bracket, keep in mind that it multiplies with everything. Now, it's your choice whether to simplify first, then multiply, or first multiply, then simplify. That's entirely up to you. It's as per your convenience. So now when we multiply over here, what do we get? Let me use a black marker. So this is 2x plus 3 whole square minus 18 plus 11. This is 2x plus 3 whole square minus 7. Take care of the positive negative sign, and that is what you get. Now, right away, underneath it, have a habit of writing ax minus h whole square plus k. That is the gold standard for completed square form. A is positive, that is the shape. Minus h is plus 3, h is -3, k is -7. -3, -7, that is a turning point, which is in fact a minimum point. Now this thing is done. Now the next part, it says find an expression, sorry, the function f is defined by such and such for x is less than or equal to -4. Now the thing is, it's about lesser than or equal to -4. Now keep in mind, the turning point, which is this thing, -3, -7 is somewhere over here. This is -3. And let's say this is -7. That is the turning point. But the domain over here, it's starting from x is less than or equal to -4. So let me plug in -4 in this equation and let me evaluate. So f of -4 is coming out to be -5. So therefore, -3 is here. This is -4, and somewhere over here is -5. Okay. That means the graph is like this. And this is the turning point, but we are starting somewhere over here. So let me use a curved line like this, and the graph is going like this. So now, based upon the looks of the graph, let's look at it. This is -5. This is this. So if I write domain, x is lesser than or equal to -4, the range is if x is greater than or equal to -5. The range of f is the same thing as domain of f inverse, x is greater than or equal to -5. This thing is done. Remember the strategy that was told in class. We have fx, we have f inverse x. This is the domain, this is the range, this is the domain, this is the range. Domain becomes the range, range becomes the domain. Now this thing is done. Find an expression for f inverse. Nothing special except for one point. That is, first of all, we have to use the completed square format, which is what? Which is 2x plus 3 whole square minus 7. Because if we don't use it, we cannot make x the subject. Then we will write, let me write everything in black. Then we will write, let y is equals to fx. Therefore, f inverse y equals to x. So therefore, y is equals to 2 bracket square minus 7. Y plus 7 divided by 2 is bracket square. Square root y plus 7 divided by 2 is x plus 3, x plus 3, x plus 3. And now we give it a negative sign. Why? Because the original function is quadratic. We are going left of turning point. So therefore, the square root will have a negative sign. X is equals to minus 3 minus the square root, y plus 7 over 3. And what is x equals to? X is f inverse y. So finally, f inverse x is equals to negative 3 negative x plus 7 divided by 3. So that is what we are getting. I think it's divided by 2. By mistake, I wrote 3. So let me correct myself. And over here, so there is a 2, there is a 2. That is the expression. Now the next page, it says the function gx is defined by such and such for the case where k is equals to negative 1. So now we have gx is equals to 2x minus 3, x is less than or equal to negative 1. Solve this equation. So f of gx, what is f of x? F of x is 2 bracket x plus 3 whole square minus 7. F of gx goes inside. So therefore, 2gx plus 3 whole square minus 7. When we simplify, we get this thing as 8x square minus 7. Now equate it to 193. 8x square minus 7 is 193. 8x square is 200. X square is 25. Therefore, x is negative 5. X is positive 5. But the domain of fx, first of all, is less than or equal to negative 4. The domain of this thing is less than or equal to negative 1. So therefore, we reject this and we accept this. So that's the only answer. Solve the equation. Now this thing, state the largest value of k possible for the composition fg to be formed. Now, first of all, what does fg means? Fg means, let me correct this thing. Fg means first G, then F. So now I'll explain something more than what is required in this particular part because it could be asked in some other parts. So let me draw some circles like this. And the thing is first G, then F. So let me write this as first G, then F, and this is written as Fg. Okay, that's the first thing. Now, this is domain of G, range of G, domain of F, range of F. Now, largest value of K for the composition Fg to be defined. For Fg to be defined, in order for this function to exist, it is necessary that the range of G should be a subset of domain of F. Range of G should be a subset of domain of F. Now, first of all, what is the domain of F? The domain of F is this thing. So let me write over here. So first of all, domain of F is x is less than or equal to negative 4. Range of G is just this expression right away. So that is 2x minus 3, x is less than or equal to k. So this is gx, 2x minus 3, x is less than or equal to k. So let me write gk, that is 2k minus 3. Now take this thing and insert in this place because we have to find the maximum possible value. So 2k minus 3 is less than or equal to negative 4. 2k is less than or equal to negative 4 plus 3, which is negative 1. Therefore, k is less than or equal to negative half. So this is negative half. All the values lesser than this. So what is the maximum value? What is the greatest possible value? That is k is equals to negative half. So that is the working that needs to be done for 1 mark. But the logic is very deep. Now, also remember that the examiner can ask us, what is the domain of Fg? Domain of Fg is domain of G. What is the range of Fg? Range of Fg is range of F, provided these two are exactly equal. And if these two are not equal, we will take the overlapping value and then we have to calculate. So that's all about this thing, that is quadratics and functions. Differentiation and integration. Now this first question, it says in the diagram, S is the point 0, 12, T is the point 16, 0. The point Q lies on ST between S and T and has coordinates XY. The points P and R lie on the x-axis and y-axis respectively. OPQR is a rectangle. Show that the area of the rectangle is given by such and such. Given that x can vary, find the stationary value of A and determine its nature. So it's been a long while that they have asked any question related with coordinate geometry and differentiation and maxima and minima and mensuration. So let's revise this idea. First of all, let me mark this point as Q. This is 0, 12 and this is 16, 0. There are two approaches to this. Either I can use the concept of collinear points, or I can find the equation of a line and then plug in Q. So either way it would work. So let me write down that SQT, this is a straight line. And if it's a straight line, the gradient is change in y over change in x with a negative sign. That is negative 3/4 and the y-intercept is 12. So therefore the equation is y is equals to minus 3/4 x plus 12, and that fulfills this criteria for x and y. That means x and y could lie on this line. So this is perfect. So now what else do I need? What I need is that this is the length and this purple one is the height. So now over here, what is the length? The length is x. What is the height? Which is y. So therefore, black marker, area of rectangle, which is OPQR, that is equals to xy, which is x into minus 3/4 x plus 12, which is equals to minus 3/4 x square plus 12x, and yes, that's the answer. So the first part is done. Now the second part, that is related with differentiation. Given that x can vary, x is a variable, find the stationary value of A. So therefore what we do is that we differentiate A with respect to x. So this is negative 3/4, derivative of x square is 2x, 12x, the derivative is 12. And we equate it to 0 to find the stationary value. So therefore 2 1s are 2 2s are negative 3/2x plus 12 equals to 0. Negative 3/2x is negative 12. Therefore x is 2/3 of 12. So 3 1s are 3 4s are 4 2s are 8. So x comes out to be 8. That is the stationary value of x. But we need to find the stationary value of A. So therefore A is negative 3/4 x square plus 12 into x. So that is negative 3/4 into 8 square, which is negative 3/4 of 64. And this is 12 into x, that's 12 into 8, which is 96, and we get this value. What about the determining the nature? Let me add a page over here. So we know that dA by dx equals to negative 3/2x plus 12. Negative 3/2x plus 12. This is the simplified expression. D square A over dx square is negative 3/2. This is negative, therefore it's a minimum. Let's check in the values. So the first part was proof. X is 8, A is 48. So this value, which I have not evaluated, is 48. And yes, it's a maximum. My bad. Because the second derivative is negative, so negative means a maximum. So that is what happens when you are in a hurry. So what is the key message? That is always recheck. Now this question, I'll simply set up the idea of what needs to be done. The diagram shows part of the curve, that is this one, and a point P 6 5. So P is 6 5. Lying on the curve, the line PQ intersects x-axis at Q 8, 0. Show that PQ is a normal to the curve. So let me grab this red marker and something, this is purple actually, and that goes like this. Show that PQ is a normal to the curve. Now what we do is that, let me write y is equals to 1 plus 4x raised to power of half. Let me differentiate dy by dx. Half comes down, 1 plus 4x remains as it is, power reduces by 1, derivative of bracket is 4, which is 2 over square root 1 plus 4x. Now the tangent is at 6. So when x is 6, therefore dy by dx, so dy by dx equals to 2 over 4 into 6 is 24 plus 1, 25. Square root of 25 is 5. The gradient is 2/5. So gradient of tangent is 2/5. Therefore, gradient of normal should be negative 5 over 2. That should be the same between the points P and Q. So P is 6, 5. Let me write it properly so that the examiner knows exactly what I'm doing. That applies to you as well. This is 8, 0. Gradient of PQ, that is 5 minus 0 over 6 minus 8. This is 5 and this is negative 2. Yes, we have proven that the gradient of PQ is the negative reciprocal of gradient of tangent, and that makes perfect sense. Second part, it says find, showing all necessary working, the exact volume. Exact means fractions, exact means third form, exact mean in terms of pi. Revolution obtained when the shaded region is rotated 360 degrees about the x-axis. So now first of all what we do is that let me draw a dotted line over here. This is 6, this is 8. This is the region under a line, and this region over here, that is under this curve. Now the examiner is giving us a hint that is that when we rotate this thing, the volume of a cone is like this, because when it is rotated, this goes like this. So this one would be the radius, this one would be the height. You can do that, or you can also use integration. That's your choice. This one over here, what is that? That is volume under the curve. So this is volume under two separate graphs. So let me add a page over here. First of all, we will write volume under the curve. That is pi. What are the limits? The limits are 0 and 6. It's around the x-axis. So the limits are on the x-axis, and the equation is what? 1 plus 4x raised to power of half, 1 plus 4x square root. Don't forget to square and then dx. I'll just simplify it a bit. And over here, 6, 5 and 8, I have the gradient. That is negative 5 over 2. So we have gradient of PQ, that is negative 5 over 2. And I can write y minus y1 is mx minus x1. Y minus something is negative 5 over 2x minus something. So now it's my choice whether I use P or I use Q. Let me use Q, which is 8, 0. So this is y minus 0 and this is x minus 8. So y is equals to minus 5 over 2 x minus 8. So volume under the line, that is between the limits pi 0 and 6. No, it's not 0 and 6. It's 6 and 8. And this is minus 5 over 2 x minus 2 whole square dx. Let me simplify it further. This is 5 over 2 after squaring. That becomes 25 over 4. Take it on the outside. Pi is still there. This is 6. This is 8. This is x minus 2 whole square dx. Now integrate. 25 over 4 pi. This is x minus 2. Raise the power by 1. Divide by the new power. Divide by coefficient of x. And then plug in the limits 6 and 8. And you leave the answer in terms of pi. Something in terms of pi. Volume under the curve, that is first square, so this becomes 1 plus 4x. dx, the square root disappears. Now it's your choice whether to integrate it term by term or to integrate it as a bracket. Let me do this thing term by term. So x plus 4x square over 2 between the limits 0 and 6, and you get this something pi units cube. And this will also be pi units cube. And therefore, the total volume, that is volume produced by the curve plus volume produced by the line. Now, if I were to find this thing using the cone thing, just don't confuse the radius. So now it's going like this. So therefore, the radius is this thing, which is the y coordinate 5. And the height is 2. So we can write radius is 5, height is 2, volume of the cone is 1/3 pi r square, which is 5 square into h, which is 2. So 25 into 2 is 50, 50 pi over 3 units cube. So naturally this looks easier than this one. So it's your choice. So now this thing is done. And that's the volume for the line, and this all this thing is over here. Now this thing, a lot of people, they ask this question, they haven't asked this thing for a very long while, so let me do this thing also. That is, the diagram shows part of the curve, and I'll just focus on this thing, the angle between the two things. Integration, that's basic, I'll simply write it down. So now it says the diagram shows part of the curve such and such intersecting at P01. So this is P01 and Q23. The angle between the tangents to the curve at Q is alpha. So now let me focus on this line, that's the purple line. That is for this, and this for this is the line like this. We need the angle between these two. So if I do the working for this one versus the working for purple, so let me show you the working for both. So y is equals to 4x plus 1, and it doesn't make a difference if I mix up the lines because it's not based upon diagram, it's based upon calculation. Diagrams are just for fun. Raised to power of half. Dy by dx, that is half 4x plus 1 raised to power of negative half into 4, just like the previous question, which is 2 over square root 4x plus 1. Y is equals to half x squared plus 1, therefore dy by dx is half into 2x, which comes out to be x. When x is 2, dy by dx equals to 4 2s are 8, 8 plus 1 is 9, square root of 9 is this, so this is 2/3. When x is 2, dy by dx is x, which is 2. So angle produced by the red line, let me call it theta1, that is tangent inverse of 2/3. Angle produced by the other line, theta2, that is tangent inverse of 2. What is the logic? The logic is tangent theta equals to gradient of the line, or theta is tan inverse of gradient, a very, very important concept. Now I have grabbed my calculator and I'm working in the degree mode. So therefore tan inverse, so shift tan I've written, and I've written a fraction and 2 and then a 3 equal sign. This comes out to be 33.69 degrees. 33.69 degrees. Tan inverse of 2, I remember this value, that is 63.43. So therefore the difference is the answer because both slopes are positive. So minus 63.43, this comes out to be 27.74. 27.74, which comes out to be 27.7 degrees, correct to 1 dp, no harm in double checking. So this is 29.7, my bad, I wrote it down wrong. So I did the calculation right, but in a hurry, I wrote it down wrong. So this is 29.74, 29.7, and that is the answer. As far as the integration is concerned, that's very easy. It's area under the top graph between the limit 0 and 2. Area under the bottom graph between 0 and 2 and subtract. So that was the easy part, nothing special with that, just pointing out that these kind of questions can come. Now let's look at this question. This question says the diagram shows part of the curve with equation such and such and the line. So now there is a curve that goes like this and the line OA that is going like this, where A is the maximum point on the curve, the x coordinate of A is small a, and the curve has a minimum point at P, 0. So this is minimum, this is max. Show that B is equals to 3a. Now let's see how to proceed with this. Y is equals to x cube minus 2bx square plus b square x. Remember, x and y are variables and a and b are constant. Dy by dx, that is 3x square minus 2b as it is, derivative of x square is 2x, and b square as it is, derivative of x is 1. So simplify 3x square minus 4bx plus b square. Now what we do is that we are dealing with turning points. So dy by dx equals to 0. Therefore, 3x square minus 4bx plus b square equals to 0. Now we know that one of the turning point is definitely a. So let me plug in a. So when x is a, 3 into a square minus 4 into b into a plus a square is equals to 0. So this is 3a square. This is 4ab. This is a square is equals to 0. Therefore, negative 4ab. Let me take a common out. I think that would be a better idea. So 3a square plus a square, 4a square minus 4ab is equals to 0, because it's our habit of always taking common out so that we don't lose any of the solution. This is a minus 4 common and a common, and a minus b equals to 0. So I have b is equals to 3a. Have I done any mistake? Let me double check. So this is 3x squared, this is 2b into 2x, that's 4bx, that is perfect. This is b squared and x is 1. And this is 3x squared, 4bx, b squared, perfect. Dy by dx is 0, 3x squared minus 4bx plus b squared is equals to 0. 3 into a squared, 4 into b into a plus, oh my bad, this is b squared. That is the mistake that I've done. So now let me correct myself all the way over here. So now this is b squared. This was not a squared. This is b squared equals to 0. This is plus b squared equals to 0. So now what do? We have to show that b is equals to 3a. So now can we factorize? This looks like middle term factorization to me. So this is 3a squared into b squared is 3a squared b squared. So this is 3a squared minus 3ab minus ab plus b squared is equals to 0. 3a minus b minus ba minus b equals to 0. A minus b, 3a minus b equals to 0. Therefore, a is b. Therefore, 3a is equals to b. A is equals to b. That is not possible. How can you have the same value for a and b, whereas from the graph we know that these two are different? So this is what we have proven. So that is the thing. And then it's about finding the area in terms of k. That's not a big deal. So that is something about differentiation, integration. Now let's move to circular measure. And that is the last thing. And before that, let me get the thing ready. That is the grade threshold. That is one thing that I wanted to emphasize on. And the exam report and the AS exam report, I think that is, let me pick 2022 or 2023. I think I should have it. So this is the P1 paper, not this thing, the booklet. And yes, something over here should be there. Okay, so just a random variant like this. Okay, so this is June 2023 and I'll be focusing on this. Let me first focus, because then at the end we'll do a question, and that is this thing. This is 2023. Perfect. Now the questions, the examiner report, it's not always a question, it's based upon questions. The syllabus for the paper changed in 2020 and the new topics including circles and transformations were introduced. Many candidates seem very confident, but others may have required further practice on them. The previous three reports, this is the main thing that I want to focus on. Let me erase everything, just the main thing. No marks will be given for unsupported answer from a calculator. Show all the working. Clear working must always be shown to justify solution. For quadratic equation, it would be necessary to show factorization or the use of quadratic formula or the completing square as stated in the syllabus. Using calculator to solve equation and writing down only solutions, it's not sufficient. Similarly, it's also insufficient to quote only the formula. Candidates need to show values substituted in it. Factors must also produce the coefficients of the quadratics when expanded. So make sure that you have done the factorization correctly. And then the second thing, that is sufficient time to finish the paper. Presentation of work was mostly good, although some of the answers were initially written in pencil and then superimposed in ink, giving a very unclear image when the script is scanned. Make sure that you don't do this mistake. And over here, coming to this, so let's talk about component 1-2. Out of 75 mark, that was a very difficult paper. That's why it was 49. But if I talk about component 1-3 of last year, that was 62, or component 1-1 was 50. So let's say what I feel is that you will have a paper in which the threshold will be 57 to 58 out of 75. This is the range for getting an A. So that would be a moderate paper. Now, if you find anything difficult, just leave that part and come to it at the last. So last, do come to that difficult part, but do not argue with it. Do not waste all your energy. Do not lose temper on that. Keep that in mind. So now going back to this, the question paper, which is over here, circular measure. So let me show you this working. The diagram shows a semicircle with center O and radius 6. That means this thing, OA is the radius, OB is the radius, OC is the radius, and then OC is perpendicular to diameter, point D lies on AB, DC is an arc of a circle, center B. So DC, that is this thing, another color. That is arc of a circle, center B. So therefore, this goes like this goes like this, and that's how this thing is made. Calculate the length of the arc, and then find the value of area of region P, area of region Q, giving you answers to 3 significant figures. We can work in exact form also, because the examiner can have a change of mood and ask in any different format. Now, first of all, what I need to do is that this angle over here, because this is an isosceles triangle, so this is 90. So therefore, this angle is 45, this angle is 45, 45 is pi by 4. S is equals to r theta, area is half r square theta. This is what we need. Now, let me focus on the next part. If I want the length of arc CD, that is nothing special except that if this is 6, this is 6, we need to find BC. So therefore, BC square is 6 square plus 6 square under root, that is root 72. Therefore, arc length BC is root 72 into pi by 4. 72 can be written as 36 into 2, that is 6 root 2. So this is 6 root 2 into pi by 4. That can be written as 3 over 2 root 2 into pi. I have written the answer in the exact form because it does not specify whether decimals or exact. So I personally like exact form. Now, as far as the area is concerned, that is area of region P, area of region Q. So basically, Q plus this triangle is sector BCD. So let me just do the working over here. So sector BCD is region P plus triangle. What's the name of the triangle? That is OCB. Sector BC is half r square, that is root 72 square into theta is pi by 4. Region P is what we are looking for. And let me write area of P like this. Area of P and area of triangle, it's half base into height. So the 72 is gone. So this is half 72 pi by 4. This is 36, actually minus 36 equals to area of region P. So 2 ones are, and actually 2 and 4 is 8, 8 nines are 72. So this is area of region P is 9 pi minus 36. I'm writing in the exact form. If I need decimals, I'll do it at the very end. Now what else is there? This thing, AOC is a quarter circle. From the quarter circle, if I subtract Q, I'll get P. So AOC is a quarter circle. That is 1/4 of a circle. So 1/4 area of circle. If I need area of quarter circle, so that is 1/4 into pi into r square. So 6 square is 36. 36 over 4 is 9 pi. So therefore, this 9 pi is actually what? This 9 pi is P plus Q. So this is area of P plus area of Q. Therefore, area of Q is 9 pi minus area of P. That is 9 pi minus 36. 9 pi cancel. Minus minus cancel. That is 36. So therefore, the ratio, and what is at the top? P is at the top, Q is at the bottom. P is at the top, that is 9 pi minus 36 over 36. That is the answer in the exact form. If you are using the calculator, you can get the answer like that, and that is what the thing is. So this is 18 and 18. Why is it 18? So let me just double check if I have missed out anything. Now, first of all, over here, what do I have? This thing is exact. That is good. Sector BCD. Sector BCD is BCD. So this is root 72. That's right over here. And half r square theta. Theta is pi by 4. So this is half into r square 72 into 4. 2 into 4 is 8. 8 into 9 is 9 pi. And 6 into 6 is 36. So now such a small mistake. This is 18. And over here, this is 18 again. So this small mistake. And over here, this I think it's also 36 is becoming 18. And this is 18. And this is 18. So let me correct all these small silly mistakes. So that is 18. That is 18. That is 18. So 9 pi minus 18 divided by 18. Actually, it's q at the bottom, so q is 18. So now double check. So this is 18 over 9 pi minus 18. It's the upside down, and that doesn't make a difference because if it's the other way around, p over q, and then you get the answer. So one last question before we go, and that is this thing. A question that has once appeared long time ago, many years ago in Add Maths, and now it's appearing also over here. I'm just charging my Apple Pencil, as you can see. So just have a look at the diagram. The diagram shows the sector of a circle with center O and radius 20. So sector, that's the big one. Radius is 20. A circle with center C and radius x centimeter lies within the sector. And it touches PQR as shown. PQR is 1.2 radian angle. Show that x is this. Find the total area of the three parts of the sector lying outside the circle with center C. Find the perimeter. So main thing is the first part. Let me just focus on the first part and then you are all set to go. So now the thing is, let me join it with some points. First of all, this thing is x. That's right over here. That means C to R should also be x. That means this thing over here, O till C, is something else. And this thing is the green one. Now, let me choose the green color, and that's like this. Now, what do we have? First of all, what I can see is that the OQC is x, OC is unknown, and I know that OQ, so we have OQ that is equals to 20. Now, this thing, CR, this is also x. And this OC, can I write OC as 20 minus x? Yes. This whole thing is 20, just like this. This much is x, so OC is 20 minus x. And then there is a 90-degree angle because radius is perpendicular to tangent, and this angle becomes 0.6 radians. So I'm just proving the first part, that a sine of 0.6 is equals to x divided by 20 minus x. So I'm grabbing my calculator, and there is the calculator. Make sure it's in the radian mode, that you need to make sure. And this is 0.6, and I'm pressing the button for sine. That comes out to be 5646. 0.5646 into 20 minus x is equals to x. So multiply it with 20, that is 11.2928. 11.29, let me make it, 29 is good. Minus 0.5646x is equals to x. So therefore, 11.29 divided by 1.5646, this comes out to be 7.216, something like that. And yes, I get my answer. So that was the strange kind of a question that you have come across. This is of November 2012. And then it's all about finding the area of this and area of this and area of this. So that is the area of the big sector minus the circle, and you get this thing. Find the area of region OPSR bounded by the arc PSR. So where is PSR? That's PSR, like this. So you would be working with this particular angle. So if this is 0.6, this is pi by 2. Therefore, this one is pi by 2 minus 0.6. Double it, you get this whole angle. Work out this arc length and the lines OP and OR. So this you need to find. This you need to find how? By Pythagoras theorem. So now you're all set for the exam, and wish you the best of luck so that you get a very, very high grade on all your papers, especially P1, and then S1 is creeping and it's on the way. Take care.